Hi, everyone. So I thought it might be helpful this weekend to have the solutions to all these tic-tac-toe problems that we're talking about in class on Friday. So I thought I'd go over them now, and you could have access to this video if you needed some extra help this weekend preparing for Monday's quiz. Okay. So I'm going to start here and go across and then down. And then I'll flip onto the back and do the same thing. Okay? All right, so let's see. The top left corner says y varies inversely with the square of x. Y equals k over x such that y equals 12 when x equals 6. So if I solve for k by multiplying both sides by 6, oh, I'm sorry, y varies inversely with the square of x. I only did y varies inversely with x. That needs to be squared, that needs to be squared, so I need to be multiplying by 36 on both sides. Okay, so 12 times 36, I get 432. K equals 432. All right, so my variation model then would be 432 over x squared. Then I notice it says find y when x equals negative 3. So y equals 432 negative 3 squared, which is 432 over 9, and 432 divided by 9 is 48. So y equals 48 is my answer to number 1. Let's take a look at number 2. Number 2 says, given f of 2 equals 6 and f of negative 1 equals 12 are points on a line f of x. Write the equation of the line parallel to f of x passing through this other point. Well, we did this in our graphing basics unit, but we were using ordered pairs. And that's why this is in the functions test. We already know how to write the equation of a line. We already know how to write the equation of a line parallel to another line. What's new here is the function notation. I have to recognize that this is this ordered pair and this is this ordered pair. So with two ordered pairs, can I find the slope of the line connecting them? Sure. We remember the slope formula, y2 minus y1 over x2 minus x1. Please don't write y equals mx plus b. That's not the slope formula. That's called the slope-intercept form of a line. This is the slope formula. The slope formula requires me to plug my y's in on top and my x's on the bottom. And so I get 6 over negative 3, which is negative 2. So I know the slope of f of x, the slope of the line connecting these points, is negative 2. What would be true about any line parallel to this line? What slope would that have? Well, we know that parallel lines have the same slope, so my parallel line would have a slope of negative 2 as well. But my parallel line is supposed to pass through 2, 1. So I'm supposed to use the ordered pair 2, 1 to write the equation of the line. Y equals mx plus b slope-intercept form is a fine way to write the equation of the line. I myself probably would have used point-slope form here, but most students prefer to use slope-intercept form. I'll plug in my slope and my ordered pair so that I could solve for b. And when I add 4 to both sides, I get that b equals 5. Now we're not quite done yet. We need to write the equation of this line. This is just the y-intercept of that line. The equation of that line is what we get when we plug this b value and this m value back into y equals mx plus b. Y equals negative 2x plus 5. Okie doke. So there's number 2. Number 2. The line that is parallel to the line that passes through these points. So it has to have the same slope as the line passing through these points. But our parallel line has to be able to pass through this other point, 2, 1. This line doesn't pass through 2, 1, it passes through 2, 6. We want a line that passes through 2, 1. This is that line, parallel to this one, but passing through 2, 1. All right, let's take a look at number 3. Number 3 gives us a piecewise function and asks us to find f of negative 2. So when I look at this piecewise function, I notice there are 3 pieces. Please also notice these things over here. These things over here are domains. I only use this middle piece for x values between negative 3 and 0. I only use this linear piece up here for x values that are smaller than negative 3. For x values that are bigger than 0, I use this parabola piece down here, and only this parabola piece. So where does negative 2 fit into all of this? Is negative 2 less than negative 3? Is negative 2 between 0 and negative 3? Or is negative 2 bigger than 0? Well, negative 2 is between negative 3 and 0, so I have to plug that negative 2 into this piece. 2 times negative 2 plus 1. Negative 4 plus 1 is negative 3. So f of negative 2 is negative 3. That's it. That's my answer. Please don't plug the negative 2 in here, because negative 2 is not smaller than negative 3. Please do not plug the negative 2 into these x's, because negative 2 is not bigger than 0. And please do not plug the negative 2 into these domains over here. Please. Okay, so my answer to number 3, f of negative 2 equals negative 3. Number 4. In each case, which of the following cases is y a function of x? Well, when we talked about functionness in class, we said has to pass the vertical line test. When I look at y equals x squared plus 1, I know that that's a parabola that's been shifted up 1. I know that this passes the vertical line test, so I know A works. What about B? X squared plus y squared equals 1. Well, after we had our algebra basics, we talked about graphing circles, and this is a circle. This is a circle, x minus 0 squared plus y minus 0 squared equals 1. The center of our circle is 0, 0. The radius is 1. Well, think about a circle with a radius of 1. Does that pass the vertical line test? Nope. I crossed twice. So this is not y as a function of x. What about C, y squared plus 1 equals x? Well, y squared plus 1 looks like this. And if you're not sure, you could always subtract 1, get y squared equals x minus 1, and then take the square root of both sides. Remember, when you take the square root of both sides, you have to remember the plus and minus. Here's positive square root of x minus 1, and here's negative square root of x minus 1. Does this pass the vertical line test? Nope. And what I said in class was, you may recall this, is if you see a y squared, that's not y as a function of x. Okay? So there's number 4. Number 5, the center square, the difference quotient. We see that f of x equals 2x squared minus 3x. And we're given this difference quotient f of 3 plus h minus f of 3 all over h. And when we talked about the difference quotient, we said that this was a 4-step recipe. The first step would be to find f of 3. Well, f of 3 is what I get when I plug a 3 in for all the x's. 3 squared is 9. 9 times 2 is 18. 3 times 3 is 9. And so I get 9. Okay? What about second, finding f of 3 plus h? So I get 2 times 3 plus h squared minus 3 times 3 plus h. Finding f of 3 plus h just means plugging in 3 plus h for all these x's in f of x. Don't distribute first. Remember, we're doing PEMDAS, exponents before multiplying. So I have to FOIL first, and I'll get 9 plus 6h plus h squared minus, don't forget to distribute that negative here, negative 9 minus 3h. I still need to distribute this 2 everywhere, and so I'll have that f of 3 plus h equals 18 plus 12h plus 2h squared minus 9 minus 3h. If I combine like terms here, I can turn this into 9, and here into 9h plus 2h squared. Okay? So that's f of 3 plus h. Now let's look at this difference quotient again. Step 1 was find f of 3. We did that. There's f of 3. Step 2 is to find f of 3 plus h. So f of 3 plus h is this here. And then, step 3, subtract these two things. 9 plus 9h plus 2h squared minus, what was f of 3? F of 3 was 9. So when I do that subtraction, the 9's cancel, and I have 9h plus 2h, h squared over h. I'm almost done. The fourth step is divide by h. So if I factor an h out on top and cancel it with the h on the bottom, my answer is going to be 9 plus 2h. Okie doke, 9 plus 2h. I'm just checking. There's 12h, 3 times 3 times 2 is 6, times 2 is 12h, and over here we have minus 3h, and so that's 9h. Yes, that's correct then. Okay, so there's number 5. Let's take a look at number 6. 6 says, given f of x equals 8x squared plus 4x, and g of x equals 2x squared plus 3x plus 2, find when f of x equals g of x. Well, we know graphically this is asking about where does this parabola intersect this parabola. But algebraically, I'm going to replace f of x with this stuff. And I'm going to replace g of x with this stuff. And now I need to solve this equation. Since these are polynomials higher than degree 1, I want to move everything onto one side of the equation. I'm going to subtract 2x squared, I'm going to subtract 3x, I'm going to subtract 2. Subtract 2x squared, I'm going to subtract 3x, I'm going to subtract 2. On the right-hand side, I get 0. On the left-hand side, I have 6x squared plus x minus 2. I need to factor this. Some people have been telling me recently that they're still having difficulty factoring. So rather than guess and check here, I'm going to go the long way. Well, the way I showed back in the Algebra Basics unit, which was to multiply a times c and find the factors of a times c that add up to 1. All right, so what are the factors of negative 12 that add up to 1? Well, does 1 times negative 12 work? No. How about 2 times negative 6? No. 3 times negative 4? Well, they add up to negative 1. So what about 4 times negative 3? Yes, these will add up to positive 1. So I'm going to take these and replace this 1 term with these 2 terms. So now I'm going to have 6x squared plus 4x minus 3x minus 2. And what we said when we were doing this factoring before, a few weeks ago, was that we would group these in pairs, making sure to capture this minus sign in the second pair, and that we would GCF factor from each pair. What can we take from both of these? Well, certainly we can divide out a 2, but we can also take out an x. What will be left over when I divide this by 2x? 6 divided by 2 is 3, and x squared divided by x is x. And here when I divide by 2x, the x's will cancel, and 4 divided by 2 is 2. Okay, now I need to factor something out from here. And what I'm going to factor out is a negative 1. Negative 3x divided by negative 1 is 3x, and negative 2 divided by negative 1 is plus 2. Notice how we have 2 terms here, and they both have a common 3x plus 2. Well, let's GCF out this common factor, 3x plus 2. What's left over? Well, I have this left over, and I have this left over. So there's my factored form. But wait a minute, this was a solving problem. So a thing times a thing equals 0. Maybe this one equals 0, in which case x equals negative 2/3. Or maybe this one equals 0, in which case x equals 1/2. So these are the two x values where f of x equals g of x. These are the two places where this parabola intersects this parabola. Okay? Let's take a look at number 7. Number 7. Find f(g) of 3. f(g) of 3. Well, what does this notation mean? This, because of proximity, is the same as f times g of 3, or f of 3 times g of 3. Now, you have a choice. You can either multiply this f of x, x squared minus 2x plus 5, times this g of x, 3x plus 2, which is a lot of multiplying to do, this times all of this, and then plug a 3 in, or you could find f of 3, 3 squared minus 2 times 3 plus 5, 9 minus 6 plus 5 is 8, and g of 3 will be 3 times 3 plus 2, which is 9 plus 2 or 11, and we're looking for f of 3 times g of 3, which is 8 times 11, or 88. I just need to understand that this notation is the same as this notation. We know how to find f of 3 and g of 3. We plug in at 3 for all the x's of f of x. We plug in 3 for the x in g of x. This gives us f of 3 is 8 and g of 3 is 11. We multiply those, that's what this notation tells me, to get 88. Okay, that's problem 7. What about problem 8, the middle on the bottom of the board? Problem 8 says the combined girth and width equal 108. Write the formula for the volume of the carton as a function of x. Okay, well, I remember that volume of a box is length times width times height. And I notice when I look at this picture that my length is x my width is y, and my height is x. So I get x squared y. And there's volume. But wait a second. This problem said volume as a function of x. And right now my volume is a function of x's and this y. I need to find a helping equation that can help me get rid of this y and replace it with some x stuff. I see this sentence here that says the combined girth and width equal 108. Girth, remember, is the perimeter of the cross-section. The perimeter of our cross-section is this. So the girth is x plus x plus x plus x. So girth equals 4x's. But I'm told in that sentence that the combined girth and width equals 108. Well, our width in this picture is y. Our girth is 4x. So I have this helping equation here, 4x plus y equals 108. Now, how do I use that helping equation to rewrite volume so that it's only in terms of one variable? Well, I notice here that this needs to go. Okay, so if I need to get rid of y, I want to solve the helping equation for y. I want to solve the helping equation for the variable you want to get rid of. I want to get rid of y over here, so I'm going to solve the helping equation for y. If I'm solving for y, that means y is by itself. I have to get rid of the 4x. So I'll subtract 4x from both sides and get that y equals 108 minus 4x. And so over here in our volume formula, I can replace y with 108 minus 4x. Okay? That's it. All we have to do is write this volume. Next, number 9. Let's take a look at number 9. 9 says the volume of a cone is proportional to the height and the square of the radius, such that when r equals 3 and h equals 4, volume is 12 pi. Alright, well let's solve for k. 3 squared is 9. 9 times 4 is 36 equals 12 pi. And then we divide both sides by 36. And I get k equals 12 pi over 36. But wait a minute. We know that 12 goes into 12 one time, and 12 goes into 36 3 times. So my k value is going to be 1 pi over 3, also known as pi over 3. Now, I don't go any further with this problem. Normally, we would take this k and plug it back in there, but look what the question asks. Find the constant of proportionality. Did we find the constant of proportionality? We sure did. This is our constant of proportionality. Okay, so that's the front side. We're all done with it. Let's take a look at the back side. Top left corner, number 1. We've got an open-topped box formed by cutting these squares out of these corners and folding along the dotted lines. We know that this is 8 inches and that this is 15 inches. If I fold these flaps up, it's going to make an open-topped box. Now, the volume of this box is length times width times height. Well, I'm asked to write volume as a function of x, not a function of the word's length, width, and height. So I think what will help is if I can label these pieces here. This, for example, is this part of the picture. Now I know that this whole side is 15, and I know that this is x and this is x. So this little piece in here is going to be this whole 15, take away an x, take away another x, or 15 minus 2x. Now, this piece here is this. And how long is that? Well, I know that this whole thing is 8, and that this is x, and this is x. So this is going to be the 8, the whole side. Take this away, take this away. So this will be 8 minus 2x. And finally, what about the height of this box? Well, when I fold this flap up to this flap, it makes this. And these are x. So there's x. So the length, 15 minus 2x. The width, 8 minus 2x. The height, x. There's volume as a function of x. That's all we had to do, write v as a function of x. Okay, second problem. Y is proportional. Whenever I hear the word proportional or varies, I stick in that constant of proportionality. Y is proportional to the square root of x. If y equals 6, or y equals 6 when x equals 4, the square root of 4 is 2. If I divide both sides by 2, I get k equals 3. Let's plug that constant of proportionality back in and get 3 square root of x. Find the constant of proportionality. Oh, no, stop. You're done here. It's good to read the question. Okay, problem number 3 on the back. Problem number 3 says, find f of x equal to 0 when f of x equals 6x squared minus 11x minus 10. Well, f of x should be equal to 0. Here's an f of x. Let's make it equal to 0. And now I can see I'm supposed to solve this quadratic equation. Let's solve it with factoring, because I think people still need more factoring practice. We're looking for the factors of 6 times negative 10. That's negative 60. We're wondering what are the factors of negative 60 that add up to negative 11. Okay, well let's try some factors. 1 times negative 60, do they add up to negative 11? No. 2 times negative 30? No, they add up to negative 28. 3 times negative 20? That's closer, they add up to negative 17. How about 4 times negative 15? Oh, they do add up to negative 11. So I'm going to take these two factors and I'm going to replace negative 11 with these two. I'll have 6x squared plus 4x minus 15x minus 10. See how we replaced this one term with these two terms that add up to that one term? Great. So now we're going to group these in pairs. Remember to catch this minus sign inside the second pair, or your problem is going to end up being wrong. What's our GCF that we can factor from the first pair? We can take a 2 out of each of these. We can also take an x out of each of these. What's going to be left when I divide each of these by 2x? Well, here I'm going to have a 3x, and here I'm going to have just a 2. What can I factor out of each of these? I see I can take a negative 5 out. And when I divide each of these by negative 5, I'm going to have 3x, and negative 10 divided by negative 5 is positive 2. Look, we've got 2 terms here, and they have a common factor. Let's factor out that common factor, GCF factor it out. What's going to be left over? Well, left over, I've got this 2x, and I've got this minus 5. So there's our factored form. But wait a minute, we're not done. This was a solving problem. not a factoring problem. I have to set each of these factors equal to 0. So I get x equals negative 2/3, and I set this factor equal to 0, and I get x equal to 5/2. So I've got two solutions here. F of x, this parabola, is equal to 0, or has x-intercepts at negative 2/3 and positive 5/2. Okay, let's take a look at problem number 4. Which of the cases represents y as a function of x? Well, remember, I said if you see y squared or absolute value of y, these are not y as a function of x. And I see that in case A, x squared minus y squared equals 1. That's not y as a function of x. And here in B, I see absolute y minus 1 equals x. That's the absolute value of y. That doesn't work. That's going to be a sideways. That's going to be a sideways v. Right? So v plus 1. Up 1. There we go. Does this pass the vertical line test? No. It fails the vertical line test, so this is not y as a function of x. But C is a linear function in standard form. I could rewrite this as 2x minus 6 equals 3y, and see that I'm really talking about 2/3 x minus 2. This is a linear equation. It's got a slope of 2/3 and a y-intercept of negative 2. Of course this passes the vertical line test, so C works. What about D? Well, D is another absolute value, but this time it's y equals absolute value of x plus 1. Well, we know what that looks like. It looks like our absolute value graph shifted up 1. Does this pass the vertical line test? Sure it does. So D works as well. My answer for number 4 is going to be C and D, both. Okay? Now, number 5 is another difference quotient problem. Let's take a look at the difference quotient. We're given f of x equals x squared plus 3x minus 4, and the difference quotient, f of 2 plus h minus f of 2 all over h. Well, we remember from the other side that this is a 4-step process. The first step is to find f of 2. F of 2 is 2 squared plus 3 times 2 minus 4. 4 plus 6 minus 4 is 6. F of 2 equals 6. That's step 1. Step 2 is find f of 2 plus h. Well, to find f of 2 plus h, I need to plug in 2 plus h for all the x's of f of x. I need to FOIL here. I need to distribute here. I'm going to get 4 plus 4h plus h squared plus 6 plus 3h minus 4. And when I combine like terms, I see that I'm going to get h squared plus 7h, and now these 4's cancel and I'm left with 6. Okay. Step 3, subtract f of 2 from f of 2 plus h. Okay, so what's that going to look like? Well, that's going to look like h squared plus 7h plus 6 minus f of 2, and f of 2 was 6. So when I do this subtraction, I see that the 6's will cancel, and so I'm going to have h squared plus 7h over h. Remember, step 4 is I need to divide. Step 4 is I need to divide by h. So I'm going to factor an h out on top, h plus 7, and I'm going to cancel. There's the value of my difference quotient. Okay, that's problem number 5. Problem number 6. Let's take a look at problem number 6. 6 says, find f of g of 3. So this is composition, and we can do it a couple of different ways. We can find f of g of x, then plug in 3. Let's try that first. Okay, so I need to take g of x and plug it into all the x's of f of x. So f of x is equal to x squared minus 2x plus 5, and g of x equals 3x plus 2. So if I'm doing f of g of x, I'm taking g of x and I'm plugging that into each of these x's. So I'm going to get 3x plus 2 squared minus 2 times 3x plus 2 plus 5. Well, that gives me 9x squared plus 12x plus 4. Don't forget to distribute that negative. So we get minus 6, x minus 4, and then there's that plus 5. Now when I combine like terms, I'm going to have 9x squared plus 6x plus 4 minus 4 plus 5 is plus 5. So this is f of g of x, and we want f of g of 3. Well, that means I plug a 3 in for all the x's of f of x. And that gives me 9 times 9, or 81, plus 18, plus 5. That's going to be 99 plus 5, or 104. So one way to do this problem is this way, where you build f of g of x, and then you plug a 3 in. But there's another way to do this, and let's take a look at it. Find g of 3. Okay, well, g of 3 is going to be what I get when I plug a 3 in for all the x's of g of x. I get g of 3 equals 11. G of 3 equals 11. So where I see g of 3, I can replace that with an 11. Now I'm looking at f of 11. Well, how do I figure out f of 11? Well, that's going to be 11 squared minus 2 times 11 plus 5. 11 squared is 121, minus 22, plus 5, that's 99 plus 5, or 104 again. Like I said, we can do this problem a couple of different ways, and either one is fine. Okay, problem number 7. On the back side, we're looking for when f of x equals g of x. We're told that f of x is 7x squared plus 8x. We're told that g of x is negative 8x squared plus 22x plus 8. Again, because these are quadratics and I need to solve this equation, I'm going to move everything onto one side. Now, I'm not going to move these over here because I really don't want to have negative 15x squared to try and factor. Instead, I'm going to move everything onto the left-hand side. And so I'm going to have on the left-hand side now 15x squared. 8 minus 22 is minus 14x minus 8. So I need to factor this. Okay, so we're looking for the factors of negative 90 that add up to negative 14. Because 8 times 15, oh no, that's negative 120. I better check. 8 times 15. No. 8 times 15. Yes, negative 120. Okay, so what are the factors of negative 120 that add up to negative 14? Well, two numbers multiplying together to make negative means one's positive and one's negative. And because the sum is negative, the bigger number has to be negative. Okay, so negative 120 and 1? No. Negative 60 and 2? No. Negative 40 and 3? No. Negative 30 and 4? No. Negative 20 and 6? Ooh, that works. So I'm going to replace this middle term with these factors that add up to that. 15x squared plus, minus 20x plus 6x minus 8 equals 0. So we have 4 terms. We group these in pairs. We can GCF from each of these pairs. The first pair I can take out of 5x, leaving me 3x minus 4. And from the second pair, I can take out a 2 from both of these, a positive 2, leaving me 3x minus 4. So that, when I factor out the GCF of 3x minus 4, will leave me with this 5x and this plus 2. But I'm not done yet. This isn't a factoring problem. This is a solving problem. I need to solve. So I need to set each factor equal to 0. And I get x equals 4/3 and x equals negative 2/5. Those are our two solutions where this parabola intersects this parabola. Okay, what do we have now? Number 8. The volume of a sphere is proportional to the cube of its radius, such that volume equals 36 pi when r equals 3. Please watch out for this. I've seen a couple people this week say that 3 to the third is 6. 3 to the third is 3 times 3 times 3, or 9 times 3, or 27. So this is going to be 36 pi equals 27k. If I divide both sides by 27, I get k by itself. Over here, there's going to be a pi. Now I know that 9 goes into 27 3 times, and 9 goes into 36 4 times. So 4 pi over 3 is my k value. Now, I'm not done yet. I need to plug this k value back in. Volume equals 4/3 pi r cubed. See how I replaced that k value with what k was equal to, 4 pi over 3. Okay, now it says find v when r equals 5. 4/3 pi 5 to the third. Well, that's going to be 4/3 pi times 5 times 5 times 5 is 125, or 500 pi over 3. That's my answer to number 8. And then finally, number 9, the last problem. We've got to evaluate f of 5. And again, we have a piecewise function. F of x equals 3x squared plus 2x for x values that are less than 1, and a square root of 2x plus 6 for x values greater than or equal to 1. All right, well, where's f of 5 live? Is it an x value that's less than 1, or is 5 an x value that's greater than or equal to 1? 5 is greater than or equal to 1, so I'm going to take this 5 and only plug it in here. I do not plug the 5 in here, because 5 is not less than 1. I only plug this 5 in here. Square root of 2 times 5 plus 6, square root of 10 plus 6, square root of 16 is 4. So f of 5 equals 4 and only 4. Don't plug that 5 in here. Don't plug that 5 in here. These are just domains that tell us if the number is greater than or equal to 1, you plug that number in here. And that's what we did. So f of 5 equals 4. Okay, well, I hope this helps. Please use the GroupMe if you have other questions.